Hello friends, it's Sujit Wag. You're watching Wikinote channel. Welcome to the Triple E question answer video tutorial series. My dear friends, in this video we are going to discuss about the question derive the relations between torque equations of three-phase induction motor in terms of slip and maximum slip. This question can be asked for 6 marks in the exam. So let's start. So my dear friends, first of all you should know about the torque equations of three-phase induction motor. In the solution I am going to write those equations first of all, and then I am going to find out the relation between those equations. We will write the equation, that is full load torque is always given by the formula K into S into E2 brackets E2 square multiplied by R2 divided by R2 square plus S x2 bracket square. So this is my one equation. I will call this as equation number 1. Second, torque, that is starting torque TST, is just you have to replace this S by 1, so you will get that equation, and K is E2 square multiplied by R2 divided by R2 square plus S is replaced by 1, so this is x2 bracket square. So this is my equation number 2. Next, as this is starting torque, now I will go with the third equation, that is maximum torque, and it is also denoted by tau max, or I will write Tm, and it is, we have to replace in the full load torque equation, we have to replace the S by R2 by x2, and you get this equation. I will directly write this equation. I have already given the proof of this equation. You have to watch that video whose name is three-phase induction motor torque equations. So now K into E2 square multiplied by twice of x2. So this will be my equation number 3. So now I have to find out the relations between all these three torque equations in terms of slip and maximum slip. So first of all, see here, in terms of maximum torque, we have to use a maximum slip, and that maximum slip comes to be Sm, and it is given by R2 by x2. In the case of starting torque, you have to take down the S equal to 1, which is present in the full load torque equation. So we'll take down the ratio of starting torque to the maximum torque. So I will write here TST to the maximum torque, that is tau m. So starting torque, I will write down the equation, or I will write here like this, TST upon tau m, and it is given by, TST is given by, we have that equation with us. Directly I will write K into E2 square into R2 divided by R2 square plus x2 square multiplied by, as this is in the denominator's place tau m, so I will directly invert that, and I will write twice of x2 divided by K times E2 square. So now what will get cancelled? See here, this K and E2 square will get cancelled. You are remaining with twice of x2 into R2 divided by R2 square plus x2 square. Now see here, my dear friends, here you have to divide this numerator as well as denominator. Divide, I will write here, divide NR, numerator and denominator, by x2 square. So what will happen to this equation? So this equation will become twice of x2, I will write here in this fashion, upon R2 upon x2 square divided by R2 square plus x2 square divided by again x2 square. So this is my equation. Now this x2 and the square will get cancelled, and you will get twice of R2 divided by x2 divided by, here in this case if we split this term, you will get R2 upon x2, and this is whole bracket square I would say, and plus x2 square upon x2 square, and it will get cancelled, and you will get here 1. So I will directly write here 1. Just split this denominator. And what do you mean by R2 by x2? Look at this equation, and R2 by x2 is nothing but Sm. So I will just replace it, and I will write twice of Sm divided by Sm square plus 1. So this is my relation between starting torque to the maximum torque. Now I will go with the equation full load torque to the maximum torque. So TFL, I have to find out the relation between torque at full load to the torque at maximum load. So TFL to the T maximum torque, that I have to find out. And now I will go for the finding of this. So full load torque, we know the equation. So that is K into S into E2 square into R2 divided by R2 square plus S X2, and this is whole bracket square, multiplied by maximum torque. Maximum torque is given by the equation, which is the equation for maximum torque. So that is K into E2 square. So I will just replace that and I will write here twice of X2 divided by K into E2 square. So this K into E2 square, this K will get cancelled, E2 square will get cancelled, and you are remaining with the S times R2 into twice of X2 divided by R2 square plus S X2 bracket square. Now this is the remaining term. Now again, as we have done it in the previous question, previous equation, that is divide numerator and denominator by X2 square. So do the same procedure over here, and what you will get, see here. So this will be S into R2 into twice of X2 divided by X2 square upon R2 square plus S into X2 whole bracket square divided by X2 square. So we will see here now what happens over here. So this is, you can see this X2 and this square, one will get cancelled. You are remaining with twice of S multiplied by R2 by X2, isn't it? And divided by, you are remaining with R2 by X2 square. So I will write here R2 upon X2, just split the denominator, plus this will be S square multiplied by X2 square upon X2 square, and X2 square will get cancelled, and he will get just one value over here. And what is R2 by X2? As we have seen, R2 by X2 is nothing but the maximum sleep, that is SM, and this equation will become twice of S into SM divided by SM square plus S square. So this is my relation between full load torque to the maximum torque. Most of the time equations are asked on this relation. The full load torque and maximum torque are given in terms of some percentage. So if you know the relation between this, then it will be easy for solving this kind of numericals. So I will just square this bracket. Now you will go with the another, that is the third relation between the starting torque and full load torque. So I will go with that relation now. So here the third equation which I am going to find out is starting torque to the full load torque, that is toe FL. So TST to the toe FL, and we know the equation of toe ST. How to write down the toe ST? See, I have already written those equations. So you have to just take down those equations. Toe ST, that is K into E2 square multiplied by R2 divided by R2 square plus X2 square, that is toe ST, multiplied by toe FL, that is at the denominator part. So just my equation will become R2 square plus S X2 bracket square divided by K multiplied by S into E2 square multiplied by R2. So now in this equation, what terms are getting cancelled? This K cancels with K, E2 square cancels with E2 square, this R2 will also get cancelled with this R2, and we are remaining with R2 square plus S X2 bracket square and divided by S times R2 square plus X2 square. So this is my new equation now, and again follow the trick that divide numerator and denominator by X2 square. The equation will become R2 square plus S X2 bracket square whole bracket square. I will just split the term directly now. X2 square divided by X2 square divided by S multiplied by R2 square plus X2 square divided by X2 square. So R2 by X2, we know that this term is nothing but the maximum sleep, that is SM, and that is whole bracket square. So square plus here this X2 square and X2 square will get cancelled, and you will get just S square. So I will write S square divided by again S into Now split the terms, S in bracket Sm square plus you will get 1. So this is my equation for relation between starting torque to the full load torque. So hope you understood this video.
Thanks for watching this video. Stay tuned for more such videos. Please like and share this video with your friends. Also refer my website wikinode.org. Follow us on our Facebook page Wikinode Foundation. The links for the same are provided in the description box below.